Hello, more trigonometry. Let's do it. Start with example 5. That's the whole video. 2 parts. Evaluate the antiderivative of dx over the square root of x squared minus 4. That looks easy. And we're going to assume that x is strictly less than -2. Huh. Why are we doing such an easy problem, Jason? Okay, so let's do it. So we try u sub. We try think about integration by parts. Nothing's going to work out here. We're going to need a trig. Okay. Do we use sine? Nope, it's the wrong order for sine. Tangent is a plus. Going to be secant. All right. So we want x squared to be 4 secant squared. So we'll let x be 2 times secant of theta. That way we'll get the right numbers so that we can factor something out and get a tangent underneath. So dx will then be 2 secant theta tangent of theta. Specifically, let's also look at this. If x is less than -2, what do we know about secant? So it's going to be helpful to think about the graph of secant. Secant's 1 over cosine. So let's look at cosine a little bit. We'll just look at one period of cosine. This is -pi up to pi, and think about its reciprocal. Just remembering what we know about cosecant. Well, the reciprocal at 0 is going to go off to infinity, so we have asymptotes there. The reciprocal of 1 is 1, and if you remember, cosecant kind of looks like upside down-ish parabolas. Well, some of them are upside down, some of them are right side up, and it repeats forever like this. So if x is negative, and x is an output of secant, what part of secant are we using? So in our first example, we just used, you know how I said that it's like either 0 to pi over 2 or pi over 2 to pi? And that's because it's basically the same as cosine. Think about arc cosine. When we restricted the domain for arc cosine, we needed positives and negatives, so we restricted it to 0 to pi. Well, it's the same idea for arc cosine. When we restrict the domain for arc cosine, this is the portion that we use, 0 to pi over 2 and pi over 2 to pi, and that's why. So it's like 1 to 1. If x is negative, that means we're on this negative part. We need secant to be negative for this to work. So here, x being negative really just tells us that theta is in the interval from pi over 2 up to pi. Because again, this is pi over 2, and this is pi. Okay, so those are the two pieces for secant, depending on whether the x is positive or negative. And remember, x can't be between -2 and 2, because then we'd have an imaginary number. So that's very important to know. That's going to tell us that we're in the second quadrant. Cosine will be positive, sine and tangent will be negative in that second quadrant. So let's see where things go from there. Okay, so this is the integral of dx, which is 2 secant theta tangent theta, over, and again, I'm gonna save us some work. I'm gonna go off to the side and say, well, what is the square root of x squared minus 4? Well, that's the square root of 4 secant squared of theta minus 4, which is the square root of 4 times secant squared of theta minus 1. Square root of 4 is 2. It's 2 times tangent squared in a square root. This is the absolute value of tangent. Tangent is negative in this quadrant. But that's actually not a problem. So since tangent's negative or 0, actually no, specifically negative. Since tangent's specifically negative in this quadrant, the absolute value is the opposite of tangent. If it were negative or positive, we'd have a problem. But because we know it's always negative in this quadrant, it's actually pretty nice. So negative is really not that much worse than positive. So that whole denominator, just becomes -2 tangent. Oh, this is the one I flipped. I said, let's switch the order of these problems in the book because I think this one's harder and the other one's easier. Well, that wasn't the case. I'll make a note letting you guys know this. Tangent over tangent, 2 over 2. What have we got? Negative integral of secant of theta d theta. This is way easier than that other example I did for secant. Oops. All right, so antiderivative of secant is the natural log of the absolute value of secant of that angle plus tangent of that angle. No, we don't even have any secant cubes here. I'm sure you're bored. Okay, so if we have that, and again, we're remembering that x was 2 secant of theta. Oh, interesting. That tells us that secant of theta is x over 2. And tells us something about tangent of theta. What does it tell us about tangent of theta? Let's go off to the side. We know x over 2 is secant of theta, which means that cosine of theta is 2 over x. Draw a reference triangle. Why is this wrong? Because we know where theta is. We know theta is in the second quadrant. And that's going to matter here. Theta is in the second quadrant. This needs to be our reference triangle. Cosine of theta is 2 over x. Which really means that, again, we know x is a negative number. So like this is a negative right here. Kind of weird to write. Okay. So cosine's positive here, which is good. Again, really. So wait, x is negative. Theta is in the second quadrant. I want to make sure that my everything is right. Like x is negative here. I think we have to write it like this so it all works out. But anyway, it shouldn't matter for tangent, how it's written. Use the Pythagorean theorem, and we're going to get, this is the square root of x squared minus 4. Regardless of how it is, that's that square root. We know tangent should be negative. So the tangent of that theta, right, looks like this, is opposite over adjacent. We know tangent should be negative in the second quadrant. And look, our answer is negative. That's good. I'm not sure whether this has to be a negative or not, but it doesn't turn out to matter here, so I'm not going to overthink it. We get negative natural log, the absolute value of x over 2, minus the square root of x squared minus 4 over 2. And that's our answer. And again, we can bring in... All right, now let's simplify this. Or you don't have to. I'd take this as a final answer. But you could combine, right? Combine the terms like this. And then a negative is like a negative exponent. We get 2 over x minus the square root of x squared minus 4. And you could rationalize the denominator if you wanted to. I'm certainly not going to make you rationalize the denominator, but you could. Lots of stuff that you could do with this. But I'll take this as a final answer. Okay. And then, well, also we should decide which one's bigger. We should decide, do we need the absolute values? Yeah, we should really decide that. It's not fully simplified. Do we need these absolute values? And the question is our inside positive? Is this positive? Well, that's the same thing as asking, is this true? Keeping in mind that x is negative. Remember, x is less than 2. X is less than -2, he said. Oh, well. Of course, the inside's not positive then. In fact, we know this is always negative. Something negative minus something positive is always going to be negative. So we can actually simplify this even better. Is writing it as -2 over x minus square root of x squared minus 4, like so. Which really, we can, oh man, there's so many ways to simplify this. How exciting. We could really just, another way of writing that negative would be to write it as 2 over square root of x squared minus 4 minus x. And that's really nice. And then of course we could rationalize the denominator. And if we rationalize the denominator, it looks a little nicer, but you don't have to. Okay. All right. I'll cut myself off. Cut myself off. I'm pretty sure this is the right answer. We'll check our answer at the end of this video if you want. Do part B. Antiderivative of x cubed, square root of 1 minus x squared, dx. This one actually looks kind of u-subbable. Again, if you don't have to use a trig integral, don't use a trig integral. Let's try u-sub. Maybe it'll work, maybe it won't. Either way, it's a learning opportunity. There have been lots of learning opportunities in this section. So du is -2x dx, which we kind of have. I'm going to solve for dx. I think a lot of times that's easier. So if we do that, we get the integral of x cubed square root of u times dx, which is -1/2. Like this. So one of the x's is going to cancel. The -1/2 comes out in front, and we're left with an x squared. And x squared is going to be 1 minus u. This is similar to that other one where I tried and failed, but it's different. Here it works. U-sub success. Trig substitution. Dodged. I couldn't think of the word. Woo! So, square root of u times 1 is just u to the 1/2. Square root of u times u is u to the 3/2. We can take that antiderivative no problem. Add an exponent. Divide by the exponent. Add an exponent. Divide by the exponent. And all that's left is, what is u? U is, I don't remember, 1 minus x squared. Not too bad. And I said we were done, but let's distribute and simplify that -1/2. So, oh, they're both with 2's anyway. And then we can just distribute the negative as well. And write this as 1/5. All right, we can factor out. We can factor out a 1 minus x squared to the 3/2. I'm doing a lot here in one step, which is not good. Let's do it in 2 steps. Let's factor out a 1 minus x squared to the 3/2. What are we left with? First term is just -1/3, right? The second term is plus 1/5. We're left with 1 minus x squared, like so. And then it's also easiest if we factor out a 15, a 1/15. We can get something that looks pretty nice. This becomes a -5. Write the -5 over here. The other one becomes a 3. You can check our answer by distributing and making sure that it's the same thing. So it becomes something rather nice. This becomes distribute. We get 3 minus 5. It's negative 2. Minus 3x squared. We can factor out the negative, and it all becomes positive. We get something that looks real nice. Real nice and beautiful. That's the end of the video. Again, that's all you need to see. That's all you need to know. If you want to check our answers, that's what we'll do at the end. All right. So let's check our answers by taking the derivative of this and seeing if we get our original integrand. Derivative of that is going to be its reciprocal, which is the square root of x squared minus 4 minus x all over 2 times the derivative of the inside. The derivative of this inside is not nice. Okay. Let's rewrite the inside. The inside is 2 times the square root of x squared minus 4 minus x all to the negative 1 power. We need to take the derivative of this yellow guy. The derivative of the yellow guy is 2. And then we get a negative. That's negative 2 from the power rule. Inside stays the same. Subtract a power. Multiply by the derivative of that inside. We have to use the chain rule again. Derivative of the inside will be this. This guy also used the chain rule. Lots of chain rules here. What have we got? 2 over 2 cancels right there. 2 over 2 cancels right there. We got a lot going on. So I'm going to take this negative and just flip the... Now I'm going to keep the negative in front. We have square root of x squared minus 4 minus x. This guy is just that same thing squared on the bottom. That's good. And then we still have this other guy, which will be on the top. X over the square root of x squared minus 4 minus 1. So all of this cancels with one of these. And then hopefully other stuff cancels. So a couple ways of doing this. Let's get rid of complex fractions. Multiply the top and the bottom by the square root of x squared. No, I don't think that's the best way. Maybe it is. Square root of x squared minus 4. So we distribute it on the top. There's still a negative out in front. First part of the distributing cancels. Second part leaves us with this. And the denominator, the first part cancels. And the second part leaves us with this. Okay. How is this useful? Maybe it wasn't useful. Maybe I made the wrong method. Maybe the blue step was not useful. Let's try another method. This may have not been wrong. It might be fine. I might just be missing it. That's okay. Another way of doing this, let's use a different blue step. Look at this numerator. It's combined fractions. Actually, I think this is going to be the same thing, no? Divided by the denominator is the same as... This is the exact same method, no? I don't know if it's the same method or not, but I feel like I'm getting something different. So that's going to just be x minus the square root of x squared minus 4 all over the square root of x squared minus 4 times, oh, there's still a negative out in front. Let's use that negative to change the order of our denominator. X minus the square root of x squared minus 4. And now they cancel. And we're just left with 1 over the square root of x squared minus 4. Was that our integrand? Nice. All right, check our answer for this other one. Take the derivative. We have to use the product rule and the chain rule. It's actually easier to check our derivative when it was in this form, but whatever. This is good practice. Derivative of the first. Say this is first. This is second. Derivative of the first. And the reason why I'm not going back and checking it the easier way is I want to check my final answer. I want to make sure my final answer is correct. So that's what I'm checking here. Derivative of the first is going to be negative of 15 times 3/2. Inside stays the same. Subtract a power, multiply by the derivative of the inside, times the original second. Plus the first, staying the same, times the derivative of the second. Now we clean things up. This becomes negative 1/10. Oh, nope, because that cancels. Oh, and the negatives cancel. The second one, this cancels to a 2. And this cancels to a 5. There's a lot going on here, but numerator is just 1/5. 1 minus x squared, square root of that, times x, times 2 plus 3x squared. Might have to do something with that. Minus just 1/5. X times 1 minus x squared to the 3/2. Let's factor out a 1/5 x times 1 minus x squared to the 1/2. So we've factored out this, this, and this, and then one of the other guys. So we're left with 2 plus 3x squared here, and then minus 1 minus x squared that's left. 1/5 x times 1 minus x squared to the 1/2. And this becomes 2 minus 1 is 1. 3x squared minus 1x squared is plus 2x squared. This is maybe not good. All right. I lost my 2 over here. So this is 2/5, which is 2. And then 2 minus 2 is 0. 3x squared plus 2x squared is 5x squared. Now 5 divided by 5 is 0. X squared times x is x cubed. And we get x cubed, square root of 1 minus x squared, which was our original integrand. We are good to go. Everything checks out. Woohoo!